Hello, I'm Akshay Krishna and I'm going to make a video on the Java basics, collections, ArrayList and LinkedList. My registration number is 17BCE0041. So what is Java? Java is a high-level programming language originally developed by Sun Microsystems and released in 1995. Java runs on a variety of platforms such as Windows, Mac OS and the various versions of Unix. According to Oracle that acquired Sun Microsystems in 2010, Java now runs on more than 3 billion devices. Various applications that include web applications, web servers and application servers, enterprise applications, scientific applications, embedded systems, mobile applications, desktop GUI applications and so on are supported by Java. The types of applications will be explained here. Desktop GUI applications. Java provides GUI development through various means such as the Abstract Windowing Toolkit (AWT), Swing, and JavaFX. In mobile applications, Java Platform Micro Edition Java ME or J2ME is a cross-platform framework to build applications that run across all Java-supported devices, including feature phones and smartphones. Embedded systems. Embedded systems ranging from tiny chips to specialized computers are components of larger electromechanical systems performing dedicated tasks, and these use Java. Web applications. Java provides support for web applications through servlets, struts, or JSPs. Lazy programming or high security offered by the programming language has allowed a large number of government applications for health, social security, education, and insurance to be based on Java. Web servers and application servers. The Java ecosystem today contains multiple Java web servers and application servers, while Apache Tomcat, Simple Joe, Rimfax Web Server (RWS), and Project Jigsaw dominate the web server space. WebLogic, WebSphere, and JBoss EAP dominate commercial application server space. The enterprise applications JEE, the Java Enterprise Edition, is a popular platform that provides API and runtime environment for scripting and running enterprise software, including network applications and web services. Scientific applications. Java is the choice of many software developers for writing applications involving scientific calculations and mathematical operations. Why use Java? Java works on different platforms. First thing, in Windows, Mac, Linux, Raspberry Pi, and many more. It is one of the most popular programming languages in the world. It's very easy to learn and simple to use. It's open source and is free. It is secure, fast, and powerful, and it has a huge community support, tens of millions of developers working on Java, thereby making it very easy to learn Java as well as implement it, making it easy to make all the applications a person needs to. To our topic, collections in Java. The collection in Java is a framework that provides an architecture to store and manipulate a group of objects. Java collections can achieve all the operations that you perform on a data such as searching, sorting, insertion, manipulation, and deletion. Java collection means a single unit of objects. Java collection framework provides many interfaces such as set, list, queue, dequeue, and classes. ArrayList, vector, linked list, priority queue, hash set, linked hash set, tree set. This will be the hierarchy which contains the list, queue, and set and how they are prioritized. On today's topic, we'll be covering ArrayList and LinkedList in special, and we'll be looking into a program and its output on the same topic. The ArrayList in Java. ArrayList is a part of collection framework and is present in java.util package, and it provides us with dynamic arrays in Java. Though it may be slower than standard arrays, but can be helpful in programs where a lot of manipulation is in the arrays necessary. ArrayList inherits abstract list class and implements list interface. ArrayList is initialized by a size. However, the size can increase if the collection grows or shrunk if the objects are removed from the collection. Java ArrayList allows us to randomly access the list. ArrayList cannot be used for primitive types like int, char, etc. We need a wrapper class for such class cases. ArrayList in Java can be seen as similar to a vector in C++. For simple code in the ArrayList, we have package java vid, which will be my package which I've used, and we imported Java's IO package and Java's util, and this is a command line that says it's a working prototype of the ArrayList in Java. Our class is named as ArrayLi, and our main function is declared here along with the throws IO exception. Here we've put the n is equal to 5, which will be the size of the array list initially. The array list is declared here with the initial size of n. Array list integer array li equals new array list integer of n. Here the array arrli will be our object, and here we append the new element at the end of the list, where a loop for loop is used here, and the values are added here. Here the value of I will be added into the array list, and using system.out.println we print the values outside. This is used for removing the element which is present at index 3, so arrli dot remove 3. Here the value present in third position will be removed, and displaying the array list after deletion, we tend to see what is present in the array list after the deletion of the third element is present. So for printing array elements one by one, we use a for loop where the size is accessed over here, and we get the values and we print it after a space. For this program, we'll see the output. So the array list will be printed over here, and 0, 1, 2, 3, this is the position of third element, and after we put the deletion, the 4 which is present in the position 3 will be deleted, and hence this is printed. And as per the getting the value initially from one position and printing it separately, it is printed in this way. It says 1, 2, 3 and 5. We move on to linked list in Java. Linked lists are the linear data structures where the elements are not stored in contiguous locations, and every element is in a separate object with a data part and an address part. The elements are linked using the pointers and the addresses. Each element is known as a node. Due to the dynamicity and ease of insertions and deletions, they are preferred over the arrays. It also has a few disadvantages, like the nodes can be accessed directly instead we need to start from the head and follow through the link to reach a node we wish to access. To store the elements in a linked list, we use a doubly linked list, which provides the linear data structure and also used to inherit an abstract class and implement list and EQ interfaces. In Java, linked list class implements the list interface. The linked list class also consists of various constructors and methods like the other Java collections. Here we have a simple code using linked list, where my package is again Java vid, and it says this is a comment which says Java code for linked list implementation. This is where I've imported the util package, and this is the class which says linked li. This is my main function, and this is where we declare the linked list with the name object, so we can use object later on. Linked list string object, use linked list string, which is basically a string type of linked list which is declared over here, and we add the elements A, we add the element P here, C at the last, D at the first, and we add E at position 2, F and G, and we print out the linked list over here using the object. So when you want to remove an element, we either do it in one, we choose the element to be removed, so we remove the P over here, or we choose the index in which the element has to be removed, and the third positions element will be removed here, and this will be the first element will be removed here, and this will be the last one, and linked list after deletion will be printed over here. So to check which elements are present in the linked list, and we need to check whether we have an E in the linked list, we use a Boolean variable called status, and we use a function called object.contains, where we check the value of E and whether E is present inside the object linked list. If status equals 1, or the object contains E, we print out that the list contains the element E, else we print out that it doesn't contain the element E. The number of elements in the linked list is present inside size, and that will be printing out using the system.out.println, and the value of element, the second element is taken into consideration, and it's present now stored within the variable element, which is of type object. The element returned by get is first taken into account. It's stored within the element and it is printed over here. Then the second value of the object is set as y, and after all these changes the object will be printed over here. Here comes the output, where the linked list initially is D, A, E, B, C, F, G, and after that, after the deletion which we've done over here, like we've deleted B present over here, then we've deleted the third positions element, which is E, 0, 1, 2, C again, because we deleted B, so we've deleted C. Then we delete the first element, which will be D. Then we delete the last element, which will be G. So on procedure, initially B is deleted and C comes to the third position. Then we take out C. Then we take out the first element E, and then the last element, which is G. So we have A, E, F in the linked list after the deletion, and we check whether A, E, F contains E, and of course we have E inside the list, and so we print out that the list contains the element E, and then the size of the linked list is returned as 3 because we have A, E, F, and here we check for the object and we return F over here, and after the change, like the position of 2 is changed to value y, which we can see over here, which we use set for. So overall linked list can be modified using a set of functions such as add, remove, and we have set and get. So the changes can be seen in this output. Thank you for listening to this video.